Hello and good afternoon friends, welcome once again to the CEC-UGC live lecture. Dear friends, in this session today we are going to talk on a very interesting topic for all the students of chemistry. We would like to tell you that today we are going to discuss on fats, oils and detergent, and for this we have again with us in our studios Dr. K.K. Arora. Dr. Arora is Associate Professor in Department of Chemistry, Zakir Hussain Delhi College, University of Delhi. Dr. Arora has almost 32 years of teaching experience, as well as he has authored numerous entrance examinations books such as for engineering and medical students. So taking advantages from his experience, let's understand what are fats, oils and detergents. So welcoming once again Dr. Arora. I hope that this session is going to be one of the most interesting sessions, because these are the topic, or I would say this is the topic which we sometimes learn in our classes at the school level also, but going up to the higher education, what we have today in our lecture.
Hello viewers, today we are going to discuss about fats, oils and detergents. Before I start, I would like to clarify one point here, that detergent is a term that is used for cleansing agent, and soaps are part of the detergent. Generally we use two different terms, soaps and detergents. Actually the detergents that we use, they are classified as synthetic detergents, right? So we will discuss about both of these, soaps as well as synthetic detergents. Today's lecture has been planned like this, that first we will discuss that what are these fats and oils, what are their sources and what are their structure, and properties of fats and oils will also be discussed. Then we will discuss the methods for analysis of fats and oils and their common uses. Then we will talk about cleansing agents, preparation of soap, then disadvantages of soap and how it cleans the clothes or other things. Then what are synthetic detergents, how are they classified, and what are the advantages and disadvantages of synthetic detergents. So we will take all these topics one by one. Let us first move on to what are fats and oils. Actually fats and oils belong to a class of biomolecules which are called lipids. Lipids include these fats and oils, and then many other compounds. They include hormones, steroids, etc., cholesterol. These are all part of the lipids. They are one of the important food reserves of plants and animals. All animals, including human being, they have a layer of fat in their body, which is used as a reserve food, as well as it protects us from heat and cold also. Plants have this material reserved in the seeds. Generally they are obtained as oils and they are their food reserves. When a seed is sown, at the initial level for growing the plant, the food that is required, that is when leaves are not there, then that food is obtained for that growing from the stored proteinaceous materials and oils in the seeds. These oils and fats, they are water insoluble, and generally they are obtained from these sources either by the process of pressing. Pressing means the seeds are passed through the rollers, they get crushed and then oils come out, or by extraction with some non-polar solvents like ether, chloroform, benzene or any other alkane. Because these organic solvents, they dissolve oil in them, so oils are extracted in these solvents and then these solvents are evaporated, are distilled out and oils are obtained. By definition, a fat is a solid or a semi-solid at room temperature and an oil is liquid at room temperature. What does it mean? Actually, when we will talk about their structure, we will find that their chemical structure is quite close and their uses are also almost similar, but they are differentiated just on the basis of their state, and this state is defined at a particular temperature, that is room temperature which is 25 degree Celsius. So, any substance which is a solid or a semi solid, then it is a fat, and when it is liquid it is classified as oil. Generally fats include substances which are obtained from animals, and they are called as ghee or tallow, and the substances which are obtained from plants or seeds, they are mostly liquids, they are oils, that is why they are called vegetable oils. There are some other oils obtained from animal sources also, like from fish. So, a oil is obtained from fish, which is a good source of vitamin A particularly, that is oil. Vegetable oils, as I said, are mainly present in seeds, nuts, and act as a stored food for the growing embryo. Vegetable oils can be classified as edible vegetable oils or non-edible vegetable oils. What are these edible vegetable oils? Which we can consume, and non-edible vegetable oils which are not consumable by the human being. The examples of edible vegetable oils are soybean oil, groundnut oil, coconut, mustard, sesame, corn and palm, etc. So, these are important sources of vegetable oils which we generally use in our kitchen. And non-edible vegetable oils, they include oils from cotton seed, castor seed, etc. Linseed oil or flaxseed oil, it is not used for normal cooking, but is used as a food supplement because it contains high percentage of an acid in it called alpha linolenic acid, which is considered to be good for heart. We will discuss little later about this, that what is this alpha linolenic acid. Let us talk about their chemical structure. Chemically, the fats and oils are triesters of glycerol with long chain carboxylic acids, they are called fatty acids. You are familiar with the term esters. Esters are the substances which are obtained by condensation of alcohols or phenols with carboxylic acids. They lose a water molecule, and the products which are obtained, they are called esters. The carboxylic acids which are obtained from oils or fats are generally long chain carboxylic acids, and they are, that is why called as fatty acids. Since these oils and fats are the esters of glycerol, and glycerol is an alcohol with 3 hydroxyl group in it, that is why collectively these fats and oils are also known as triglycerides, or more specifically they are also called as triacyl glycerol. Means in glycerol 3 acyl groups are there. This is glycerol. This has got 1, 2 and 3 hydroxyl groups in it. Now 3 carboxylic acids form ester here, and we get a product which is called a triglyceride. These are 3 different carboxylic acids, and by a loss of water molecule between OH of this glycerol part and OH of the acid part, this ester linkage has been created here. So, there are 3 ester linkages with 3 different acids, that is why these are called triglycerides or triacyl glycerols. These carboxylic acids, they may be same or they may be different. Here they have been shown as R, R dash, R double dash, as if they are different, but there are certain oils and fats where 3 carboxylic acids are identical. From different sources, more than 100 different fatty acids have been obtained, and about 40 of them occur widely. The fatty acids are mostly unbranched and contain an even number of carbon atoms, generally between 12 to 20. Although some oils have shown to contain acids containing 3, 4, 5 carbon, etc., but most often they contain acids which consist of 12 to 20 carbon atoms. Now, Before proceeding further, let us talk about these fatty acids. I am going to talk about certain names which you generally read on the oil bottles or packets which you purchase from the market or in their advertisements. These terms as MUFA, PUFA and SFA. These are not very scientific terms, these are simple symbols for these terms. SFA stands for saturated fatty acids. That is, when the carboxylic acid present in oil is saturated, there is no double bond, right? There is no unsaturation. We call those acids as SFA. If the carboxylic acid contain one double bond, then they are simply mono unsaturated fatty acids, and they are in short known as MUFA, MUFA. Then sometimes these carboxylic acids, they contain more than one double bond, they may be 2 or 3 or so. They are categorized here as polyunsaturated fatty acids, and in short they are called PUFA, PUFA. PUFA, that is PUFA acids, are further classified based on the position of the first double bond from the methyl end of the carbon chain. Again, I will discuss it little later. So, these terms are not so special that in companies, in advertisements, they put that our oil contains more of this or more of this, although all these acids have their own uses. Right. Unsaturated fatty acids, if there is a double bond, again as you know that it might have a cis geometry or a trans geometry across this double bond. Say this is palmito-oleic acid which has got a cis geometry, and in nature it is the acid with the cis geometry is obtained, and this trans acid is not obtained in nature. Now let us come to the nomenclature part of the unsaturated fatty acids, which I said just before that these polyunsaturated acids are classified on this basis. Now this is a chain of a carboxylic acid. This is the carboxyl part and this is a carbon chain. This is an 18 carbon acid. Now in this 18 carbon acid there are 3 double bonds, 1, 2, 3. Now according to IUPAC system, when we try to name this acid, carboxyl carbon gets the position 1, and then we name further 2, 3, 4, 5, 6 and so on, and we find that this double bond begins at carbon number 9, this double bond is beginning at carbon number 12, and this is beginning at carbon number 15. So when we name this acid according to IUPAC system, its names come out to be 9, 12, 15, octadeca stands for 18, triene stands for 3 pi bonds, trienoic acid. So the IUPAC name for this compound is 9, 12, 15 octadeca trienoic acid. But when these acids are named in food sciences, they name them in slightly different way on the basis of their use or metabolic factors. In common system, the carbon next to the carboxyl is called alpha carbon, means the carbon to which carboxyl group is attached, it is alpha carbon. This is what we use in the common system of nomenclature also. And then we will name these acids as alpha, beta, gamma, delta and so on. So they call the last carbon as the omega carbon, the last carbon of the chain. It may be 18 carbon acid, 16 carbon acid, 12 carbon acid, whatsoever it is, it will be given a name omega carbon, which is the last carbon. And then from this side they start numbering as 1, 2, 3, so on. This is now omega carbon, this is carbon number 1 in numbering, this is 2, this is 3. So what we find that double bond is starting from carbon number 3, but this numbering is not according to IUPAC system, this is not from the carboxyl side. Remember, this is in food science. So this is 3, then next double bond starts at carbon number 6 and then next starts at carbon number 9. Right. So if a double bond is present at carbon number 3, then we call such acids as omega 3 unsaturated fatty acids. So, polyunsaturated fatty acids which have a double bond at the third carbon atom from the end of the carbon chain. So, from this side they will be called as omega 3 fatty acids. Suppose this double bond had not been there and it started from this carbon only, then we would call that acid as omega 6 unsaturated fatty acid, because the first double bond from this side is present at carbon number 6 and so on. Common name for this acid is alpha linolenic acid, and this has been found to be very useful acid, we will discuss later. Now, these are some naturally occurring fatty acids, saturated fatty acids. There is a 12 carbon acid called lauric acid, 14 carbon acid myristic acid, 16 carbon acid is palmitic acid, 18 carbon acid is stearic acid, and 20 carbon acids arachidic acid. These are the acids which have been found most often in fats. Then these are some naturally occurring unsaturated fatty acids. This is palmitoleic acid. This is an omega 7 fatty acid. If we see its structure, this is the omega end, because this side is carboxyl. There is one carbon, then 5 carbon written as CH2, and this is the 7th carbon, and double bond starts from 7th. It is present between 7th and 8th carbon. That is why it is classified as omega 7 fatty acid, and its IUPAC name, because for IUPAC nomenclature we will number from this side. It is first carbon, then 7 carbon is written as CH2 and then this is 9th carbon. So, double bond is starting from 9th carbon, so it is 9 hexadecanoic acid. Similarly, this is also an omega 9 fatty acid. Linoleic acid is omega 6 fatty acid, and then alpha linoleic acid we have discussed earlier is omega 3 fatty acid. So, these are some common unsaturated fatty acids which are present in oils. The 3 carboxylic acids in a triglyceride can be same or they may be different. As I said earlier, that we may have oil or fat where these 3 acids forming esters with glycerol, they may be different also, or they may be identical. This is an example in which to the glycerol 3 molecule of stearic acid they have formed the esters here, and this compound is named as glyceryl tristearate. A common name for this fat is also tristearin. If there is a same acid present, then they are named like this also, that we will introduce the letter word tri before it and then name the acid and then end with N. So, it is tristearin. This is a simple triglyceride. Those triglycerides where only one type of carboxylic acid is involved in the ester formation, we call them as simple triglycerides. But as I said before, they may have 2 different type of carboxylic acids or all the 3 different type of carboxylic acids, then these triglycerides are called mixed triglycerides. Such as this is an example where at this first hydroxyl palmitic acid has formed the ester, at position number 2 this stearic acid has formed the ester, and at third position it is oleic acid that has formed the ester. Then such an triester is named as glyceryl palmitostearoleate. That is, we will name all the 3 esters and their initial part glyceryl palmitostearoleate. This is a mixed triglyceride. So, in this way we can give a chemical name to oils and fats also. Then the ratio of the various acids vary in different fats or oils, means all the oils or fats do not have the same ratio for these acids, but it is always same in the fats and oils which are obtained from the same source or same origin. Variation in the structures and the nature of fats and oils is due to the fatty acid portion of the triglyceride, because glycerol part is same in all of them. So, where they can differ? They can differ only in the carboxylic acid part. The carboxylic acids may be different, maybe of one type, maybe of two type, maybe of all the three different type, maybe saturated, maybe unsaturated. So, basic chemical difference in all oils and fats, it lies only in the carboxylic acid part. And the oils have been found to contain more unsaturated carboxylic acids than in fats. Fats have more saturated fatty acids. Palmitic acid, which is a 16 carbon acid, and stearic acid, it is an 18 carbon acid, are the most abundant saturated fatty acids. So, wherever in fats the saturated fatty acids are present, out of those acids which I listed before, these two are very common. And then oleic acid and linoleic acid, both C18, that is 18 carbon unsaturated acids, are the most abundant ones. Again, one more thing has been observed, that if double bonds are present, they largely have cis symmetry. That is, in nature, the oils which are there, the double bond in them, they have mostly cis symmetry. Trans acid are not obtained from the natural sources, but these acids can be converted into trans acids on heating. When we use these oils for frying, some food materials are being fried. So, when we are using these oils for frying purposes, what we are doing, we are heating the oil at a very high temperature, and at that temperature what happens, the cis double bond gets converted into trans, and that oil or fat gets converted into trans fat now. Obviously, these trans fats, they contain trans unsaturated fatty acids. As I said before, they are uncommon in nature, but are formed on heating, or they are also formed during partial hydrogenation. This hydrogenation is a process which we are going to discuss later. Although these trans fats are edible, consumption of trans fats has shown to increase the risk of coronary heart disease. What happens actually, these trans fatty acids which are obtained from these trans fats in our body, they raise the level of LDL. LDL is again a short name for low density lipids. These low density lipids are also called as bad cholesterol. So, what happens when trans fats are taken in larger amount, the bad cholesterol or LDL in our body increases, and simultaneously the level of HDL, HDL stands for high density lipids. So, their ratio decreases, and HDL is also known as good cholesterol, this is good for heart. So, its ratio decreases. So, it means overall what happens when we eat or when we take trans fats as a part of our diet in our food, then LDL will increase, HDL will decrease, and that is harmful for our heart. So, that is why it is always advised not to take trans fats. So, as I said, in nature trans fats are not available, but these are formed when we use these oils at high temperature. That is why it is advised that once the oil is used for frying for a longer time, do not use it again. Means repeated frying should not be done in the oil, because every time we are frying, we are heating it, the ratio for the trans fat is increasing and it is becoming more and more harmful for us. Then let us now come to the properties of these fats and oils. Fats like butter, lard, tallow are solids at room temperature, and on the other hand oils are liquid at room temperature. This is the way of classifying these oils and fats also, and this is one of their physical property also. But even if they are solids or semi-solid, their melting points are quite low. Then all oils and fats are colorless, odorless, tasteless, and neutral substances in pure state and have a greasy feel. So, all oils and fats are colorless, but you will say that sometimes you see the oils are colored, like coconut oil is white, but the oil obtained from groundnut is pale yellow. The oil obtained from soybean is also pale yellow. then sometimes these oils might have slight odor also, but in the purest state they are all colorless and odorless. So, where from this color and odors are coming? As I told you that these oils are obtained from seeds by the process of either extraction with the solvent or pressing, and there are many other organic substances present in them. They dissolve in these oils and they come along with these oils, and they cause this odor or color. These odors and colors are removed in industry, and what we get, we call them as refined oils. So, generally what we are using in our kitchen are refined oils, and they are also tasteless. There is no such functional group which is acidic or basic. So, they are neutral chemically and they have a greasy feel. So, these are the common properties for all oils and fats. They are lighter than water and immiscible with it. All fats and oils, they float on water and they do not dissolve in it. They are soluble in organic solvents like benzene, ether and chloroform, etc., and that is why these solvents are used for the extraction of these oils also. Now, let us move on to chemical properties of fats and oils. Now, the chemical properties are due to the functional groups present in them, and these oils and fats have two types of functional group in them. One, there is an ester linkage. Second, some of the carboxylic acids have unsaturation in them, means there are some pi bonds. So, they can behave like unsaturated compounds, or they will show the properties of carboxylic esters. Now, we will not discuss all the properties which these functional groups undergo. We will discuss some of the reactions which are shown by these oils and fats particularly. Now, the CC double bond in vegetable oils can be reduced. As you know that hydrogen can be added across double bonds, and we call this process as hydrogenation. Addition of hydrogen is called hydrogenation or reduction. Now, what will happen if we carry out any oil where carboxylic acid part contains double bonds? We have carried out the process of hydrogenation. This part will be converted into saturated acids, and these saturated acids have little high melting point. So, we are converting oils which are liquid into other substances which are solid at room temperature, means we have converted oil into fat, and that is why these fats are also classified as vegetable fats, because they are obtained from vegetable oils. Other fats like ghee, which is obtained from milk, or tallow, which is obtained from animals, they are classified as animal fats. So, fats can further be classified as vegetable fats or animal fats, but one thing will be common, that they will have saturated carboxylic acid in them, and obviously in our body during their metabolism they are known to produce more of cholesterol. That is why it is advised that we should take less amount of these saturated fats. Now, this chemically, this hydrogenation is carried out at a temperature range of 175 to 190 degrees Celsius in presence of catalyst like nickel. When this reaction is carried out at high temperature, then there is another reaction that can occur, and we will also discuss that reaction is called hydrogenolysis. It can break the bond also. In this process of hydrogenation, what we have done? We have converted a liquid oil into a solid fat. So, this process is also known as hardening of oils in industry. Now, this is an example, that this is say triolene. Triolene means ester of glycerol with oleic acid, glyceryl trioleate, all the three acids are same, oleic acid, and is also known as triolene. Its melting point is minus 17 degrees Celsius. When it is subjected to hydrogenation in presence of nickel, there is one pi bond, it gets reduced, and this oleic acid gets converted into stearic acid. So, what we get is now glyceryl tristearate or tristearine. The melting point of tristearine is 60 degrees Celsius. So, at room temperature it is solid. So, we have converted a liquid oil into solid fat. The another reaction which I talked just before is hydrogenolysis. The ester bond in fats and oils undergo reductive cleavage on catalytic hydrogenation at high temperature and at high pressure. Reductive cleavage means the reaction occurs in such a way that there is a cleavage of the bond as well as simultaneously reduction also occurs. Here is an example. This is tristearine. Now, when we carry out the reaction with hydrogen at high temperature and at high pressure, this ester bond, it gets cleaved. This is OCO bond, this gets cleaved. So, one hydrogen goes to oxygen initially and one to this carbon, and this will be converted into aldehyde, and aldehydes get also reduced into alcohols. So, it is a simultaneous cleavage of the bond as well as reduction of this part into corresponding alcohol, and we get this 18 carbon alcohol called octadecyl alcohol, and this is glycerol. So, in this reaction what has happened? Cleavage as bond has occurred with the help of hydrogen, that is why we are calling it as hydrogenolysis, and we get these long chain alcohols from it. Then another reaction is hydrolysis. Lysis means cleavage of a bond, and hydro stands for water. So, now the bond is cleaved with the help of water, we call it as hydrolysis. It is different from the earlier reaction where it was named as hydrogenolysis. There the bond was cleaved with the help of hydrogen. Here the bond is cleaved with the help of water. So, just see the difference in the names, hydrogenolysis and hydrolysis. Fats and oils are readily hydrolyzed by heating with acids or alkalis because they have ester bonds, and you know that esters can be cleaved either in acidic medium or in basic medium, and the process of cleavage of esters in basic medium is also known as saponification. So, these oils and fats on saponification gives us the sodium salts of long chain fatty acids, they are called soaps. So, we will take this up little later, that soaps are obtained from oils or fats by their alkaline hydrolysis. This is an example again, this is a triglyceride. Now, when it is treated with aqueous sodium hydroxide solution, the bond will break here, this is the ester bond, it will break, H will go with this will go as glycerol, and this part will be obtained as sodium salts of corresponding carboxylic acids, and these sodium salts of carboxylic acids, as I said before, are soaps. Then there is another reaction called transesterification. Fats and oils on reaction with small alcohols like methanol or ethanol, they undergo transesterification to give methyl or ethyl esters of fatty acid. Transesterification means conversion of one ester into another by the exchange of alcohol part. What happens in this? Suppose this is a triglyceride or oil or fat, we treat it with some other alcohol. Here the alcohol, smaller alcohol is shown by R dash, and these alcohol part are written as acid part are written as R1, R2 and R3. They are the esters here with glycerol. So, when they are heated in presence of sulfuric acid or in presence of certain metal catalysts, the exchange of this alcohol part occurs, means this glycerol gets separated, and these alcohols they form esters with these acids, and we get, say, from here R1COO R dash, R2CO R dash. Now, these are the esters of these long chain carboxylic acids with small alcohols, and these are the substances which are being used as diesel, and we call this diesel as biodiesel. So, this is the work going on, and people are using different type of catalyst, and research is going on to find better and better catalyst, so that maximum yield of biodiesel can be obtained from any oil which is actually non-edible. So, we cannot eat it, but if it is converted into the biodiesel, it can be used as fuel. Then another chemical reaction of oils and fats they undergo, it is classified as rancidity. What happens? Fats and oils develop an unpleasant offensive odor when kept for few days exposed to warm and moist air, it is called rancidity. You must have seen, if oil is kept open, some oil vessel or bottle, they are left open or they are kept for very long time, you will find some sort of odor in them, some smell in them which is not good. We call this as rancidity. We say this oil has become rancid. Now, this rancidity is due to two reasons. One, these carboxylic ester bonds, they get hydrolyzed, and across the double bond some oxidation occurs. So, when the bonds are hydrolyzed, we get some sorts of acid, and if oxidation occurs across the double bond, there they get converted into corresponding alcohol part, that is carbon having OH groups attached to them. So, all this causes a thickness in the oil and a smell in the oil. This is known as rancidity. You must have seen this food items which are fried, like potato wafers or certain other materials obtained from this frying. When they are packed in packets containing some nitrogen. The oxygen is flushed out from them, because if oxygen is there, the oil in them become rancid and they will develop some smell. But if they are packed in packets where nitrogen is flushed in, so in presence of nitrogen this oxidation does not occur, means the food material, they do not get rancid and their shelf life is increased. Now, we move on to next topic, analysis of fats and oils. As I said, these fats and oils form an important part in industry, mainly as a food product, and when they have to be sold, there must be certain parameters by which their quality should be controlled, and the certain parameters which are used for checking their quality obviously based on some properties. There are many parameters which are used for oils and fats, but we will discuss here three most common parameters which are used in industry. These are saponification value, iodine number and acid value. These are the 3 points which are checked before the oils are sold. Saponification value. It is also referred as saponification number, or in short SAP, and it is defined as the number of milligrams of potassium hydroxide required to saponify 1 gram of a fat or oil. Means how much KOH is required in order to saponify. Saponification we have discussed means to break all the ester bonds. So, that will give us in the form of number, we call it as saponification value. It is a measure of the average molecular weight or chain length of all the fatty acids present. You see what happens in oils and fats, KOH will be used for breaking the ester bond, and 1 molecule of KOH will be used for breaking 1 ester bond. If that oil or fat contains long chains of carboxylic acids, then per gram of oil or fat we will have lesser number of ester bonds. And if these carboxylic acids are short chain, then in 1 gram we will have more molecules of the oil or fat, means more ester bonds, and in order to break all these ester bonds we will require more potassium hydroxide. So, higher the saponification value, that means the carboxylic acid present in that oil or fat are of short chains, short length, and if this saponification value is less, means less amount of potassium hydroxide is required, it means this oil or fat contains long chains in them. So, we get an average molecular weight from this. Then iodine number. Iodine number is also known as iodine value or iodine index. It tells the degree of unsaturation of fats or oils in it. Actually, what happens when iodine is added to oil or fat, it adds across the double bond. You know that 1 pi bond will require 1 molecule of iodine, and it is defined as the number of grams of iodine that would add to carbon-carbon double bond present in 100 gram of fat or oil. So, more is the iodine required, it means more unsaturated oils or fats, carboxylic acids are there in that oil or fat. So, greater the number of double bonds in acid residues of a triglyceride, the greater will be the amount of iodine that adds up to 100 gram, means it is more unsaturated oil. This gives a list of some acids and their ID number. Linseed oil has highest value 136 to 178, and I discussed before that linseed oil is generally not used for cooking. And this coconut oil has very little ID number. It means it contains most of the saturated oils or fats. This linseed oil, which contains more of the double bond in them, what happens when they are kept open, these double bonds in them get easily oxidized. So, in one way, if you want to use them for cooking, they will be getting rancified very easily, but they have been subjected to some other use. You must have heard the name of oil paints. These are the paints which are used to cover some wood surface or some metal surface. They have different colors in them, and these have some oils. Now, what happens when these oils along with colors are spread over these wooden or metal surfaces? They get oxidized and then they get polymerized, and after polymerization they form a protective layer over them. So, it looks good also, they get shine as well as protection, and that is why you know that if any surface, any wooden surface or metal is painted with any oil paint, it needs 8 to 10 hours in drying these days. Earlier it was taking 1 or 2 days. Now, it is not that the nature of the oil has changed these days. Actually, these days we are adding certain other chemicals to these paints, so that they get oxidized and polymerized at a faster rate. So, these are called oil paints, and mostly these oil paints contain this linseed oil in them. Then a third parameter that is used to assess the quality of these oils and fats is called acid value or acid number. The acid number is defined as the number of milligram of potassium hydroxide required to neutralize 1 gram of oil or fat. As I said before, that when oils are kept for longer time, they get rancified, some acids are produced by hydrolysis, and this neutralization with QH measures that how much acid is present in them. So, fats may become rancid after long storage, and fats or oils is hydrolyzed by different microorganisms with the formation of free fatty acids. The amount of free fatty acid present in the oil indicates the age and the quality of that oil. Thus, the high acid number will indicate the oil is old and rancid. It means we must use the oil which have low acid value or low acid number. Then uses of oils and fats. Major areas of application are in foods. They are used in the manufacture of soap, in cosmetics also, pharmaceuticals. In pharmaceuticals, in Ayurvedic medicines, many oils are obtained by boiling different herbs in normal oils, and then they become medicinal oils. Then in textiles and paper industry, paints, oil field chemicals, fat based emulsifiers, synthetic lubricants, metal working fluids, and last but not least, introduction into the transportation of fuel sector as biodiesel. So, these are the large industrial uses of oils and fats. Only small use is there where we actually eat them. Next, we take up cleansing agent. There is a long history of cleansing agent. People always have been trying to find out certain materials which can be used, and use of soap nuts. In Hindi we call them as Rita. You must be familiar with this material. It has been mentioned even in Ayurveda about it. This is the oldest material which were used for cleansing. They belong to the class of compound which chemically they contain are called saponins. And these saponins, they are chemical compounds, they are particular abundance in various plant species, and they produce soap like foaming when shaken with water. Even these days we are using the extract of these Rita material for washing hair or for washing soft woolen clothes. Soap is one of the earliest cleansing agent prepared by the human beings. As far as the history is concerned, even an old Egyptian medical document from about 1500 BC describes combining of animal and vegetable oils with alkaline salts to form a soap like material which was used at that time for treating skin diseases as well as for washing. Chemically, soaps are sodium or potassium salts of long chain carboxylic acids, which we discussed just before. Soaps are generally obtained by alkaline hydrolysis of oils and fats. This process is called saponification, and a general reaction can be written that fat or oil plus sodium hydroxide, it gives glycerol and soap. This is a chemical reaction. These ester bonds will be cleaved in presence of NaOH, we will get glycerol and the sodium salts of carboxylic acids, which are obtained as soap. As I said, soap making is one of the oldest chemical technologies. In earlier times, when knowledge was not there about the carboxylic acid or sodium hydroxide specifically, the goat tallow was boiled with wood ash to give a lathering and cleansing product. And the goat tallow at that time that was used, that contained the needed ester, and the wood ash the necessary alkali. Lot of hydroxides are there in wood ash. So, they are used as alkali in that. Although chemically our soaps are salts of fatty acids, but many variations are created when used for specific purposes. We will discuss some different types of soap that we get in the market. Color and perfumes are added when used as toilet soap. The soap generally we use it for bathing or cleaning our hands, they are colored and having some perfumes, they are added to it. Transparent soaps they are prepared by first dissolving in alcohol and then evaporating the excess alcohol. They also contain glycerol and some other oils added to them. The floating soaps. Floating soaps are prepared by beating air before it hardens during manufacture. Then medicinal soaps. They are prepared by adding certain antibacterial substances like chloroxylenol, etc. to them. These are antibacterial substances which are added. Then potassium salts of fatty acids form soft soaps, and they are used as baby soaps. The soaps which are used for children, they are always potassium salts and not the sodium salt. Their alkalinity is also maintained at low level, means pH is properly controlled, otherwise they may harm the soft skin of young children, and no pigments are allowed in baby soaps. That is why all baby soaps are always white in color, they are colorless, no color is allowed. Then we have some herbal soaps. These herbal soaps contain some fragrant essential oils obtained from different plants. Then how soaps clean the clothes, the cleansing action. Molecule of soaps, they have two dissimilar ends. At one end is a long carbon chain which is hydrophobic or water repellent, and the other end has a carboxylate ion which is water soluble end. Soap molecules have both polar and non-polar ends, and that is why such molecules are called amphipathic. So, soap is an amphipathic molecule. This figure shows the structure. You see, this is a long chain of carboxylic acid. So, this is a non-polar part or a hydrophobic part, or we also call it as a lipophilic part. Means this is water repellent. Lipophilic means it is liking the lipid part or it is a non-polar end. And this is another end, polar end. This is the sodium salt of the carboxylic part, this is charges on it, it is a polar. This is hydrophilic, means attracted by water, or this end is lipophobic. This shows here the structure again. This reddish portion and this yellowish portion shows that this is the charged end, and this is hydrophilic end, this is hydrophobic chain. Now, when soap is dissolved in water, then what happens? Their non-polar ends, they come together and they clump, and then they form a structure, a spherical structure which we call as a missile. What happens in the missile? Inside these hydrophobic ends are dissolved into each other, or they have combined with each other, and the outer ends, they have got the charges, like we show like this. These are the, that is shown in this reddish orange color, are the hydrophobic carbon chain of these soap molecules, and this blue ends with the negative charge shows the outer carboxylic acid part, carboxylate anion part rather. So, they have formed a structure which is known as missils, and the sodium ions are floating around them in the aqueous solution. Now, actually these are the missils which are used for cleansing. These non-polar or lipophilic part or hydrophobic part, they dissolve the tiny oil or fat particles which are attached on the fiber or on either surface, and due to these charged ends they have become soluble, they are washed away. So, this way they are helped in cleaning. In acidic solution, soaps will be converted into carboxylic acids, because soaps I said are sodium salts of carboxylic acids. If some acid is present, they will be converted into these soaps, like sodium stearate will be converted into stearic acid, and these acid molecules are insoluble in water. So, they separate out as scum, and this is one of the disadvantages of soaps, that they cannot be used in acidic medium. Then hard water contains calcium and magnesium ions, If these sodium salts of acids, when they are used in hard water, then what happens? They form their calcium and magnesium salts. These calcium magnesium salts are also insoluble, and they also separate as scum. So, what happens? If we are using soap in acidic medium or in hard water, lot of soap will be converted either into the carboxylic acid or its calcium or magnesium salt, which will separate out as scum, and soap is wasted, and also their cleansing action is reduced, because now suppose this is the micelle. Some of the molecule from this which have formed calcium salts, they have gone out of this micelle, because micelle they are insoluble and micelle is with the sodium salts only. So, it will not be able to clean the cloth properly. Secondly, these scum are these unsaturated the saturated acids which are formed, they may adhere to the fiber as a gummy mass, and they may even add to the hair if they are washed. So, hair look dull, and the fiber also they are not properly cleaned, they become yellowish after washing for some times with the soap in this medium. Then another disadvantage of the soap is that we add certain phosphates to them. The phosphates are added so that they can form complexes with calcium and magnesium ions, and soaps can be used in hard water also. But these phosphates are washed out to the rivers or lakes or water bodies, and they act as fertilizer there. So, what happens in those water bodies where lot of phosphates are washed out, the growth of this plant material increases, and these plants now exhaust the dissolved oxygen, and due to which the fish or other water animals they die. This process is called eutrophication. Obviously, when something has some problem, people try to search out for other thing. So, in order to find better material than soap, certain synthetic detergents were developed. Synthetic detergents vary considerably in their structure. They also have this amphipathic structure, and that is why they are used as cleansing agents. Synthetic detergents are mainly classified into 4 types. They are anionic detergent, cationic detergent, non-ionic detergent, and zwitterionic detergents. Anionic detergents are obtained either from the C12 to C18 alcohols, which on treatment with sulfuric acids give corresponding sulfates, and on treatment with sodium hydroxide their sodium salts are obtained. They are also obtained by treating the aromatic compounds having long chains with sulfuric acid, where we get their sulfonic acids, and they on treatment with sodium hydroxide they form the sodium salts. So, sodium salts of long chain benzene sulfonic acids are sodium salts of simple alcohol sulfonates. They are used as anionic detergents because cleansing action part is done by this section, which is having negative charge on it. In aromatic detergents, these chains may be branched or may be linear. So, they are called as branched alkyl group containing or linear alkyl group, and this linear alkyl group containing detergents are also classified as LABs, linear alkyl benzene sulfonic acids. We are these days using less of these branch chain containing detergents. This slide shows the comparison of the anionic detergent obtained from the alcohol. This is a long chain alcohol where sulfonic acid part is there, and that from other aromatic compound the long chain substituent is there on this benzene ring, and this is the sulfonic acid part. Anionic detergents are mostly used for laundry purposes. Then these type of materials are also added to anionic detergents like water softeners, bleaches to get whiteness, enzymes. There are certain enzymes which are added in a costly variety of these detergents. They can hydrolyze these fat molecule easily and cleansing is faster. Then certain brighteners or optical whiteners are also added, and we add certain fragrances also these detergents. Then anionic detergents are also used in toothpaste. Then cationic detergents are quaternary ammonium salts or amines with different anions. Cationic part possess a long hydrocarbon chain attached to ammonium ions. This is one example, which is cetyl trimethylamine. This is a 16 carbon chain and then 3 methyl groups. This is quaternary ammonium salts, and these quaternary ammonium salts are used in shampoos and conditioners. Cationic detergents possess some bactericidal properties also, so anti-dandruff shampoos also contain these cationic detergents. Then non-ionic detergents are those which do not contain any ions in them, and they are mostly the esters of polyethylene glycol. This is ethylene glycol, CH2CH having one hydroxyl group at the end, and when this is polymerized we get this type of chain. Here only 4 molecules are shown, but there will be long chain, but the terminal of the chain will have free hydroxyl group and in between there will be ether linkages. These are called polyethylene glycol. When these acids they form esters on 1 hydroxyl or 2 hydroxyls, we get non-ionic detergents. Like this stearic acid forming ester with polyethylene glycol, it may be having ester on one side or on both the sides. These non-ionic detergents are used in liquid dishwashing and liquid hand washing agents. And then last we have zwitterionic detergents. Zwitterions are those which have both the charge in them, positive as well as negative. These are very complex type of structures. They are not commonly used. They are also very costly. This is one example called chaps, and these are used in laboratory to solubilize biological macromolecules such as proteins, etc. Then advantages of synthetic detergents over soap. Detergents can be used in hot water as well as they can be used in acidic medium because they are neutral. There are certain disadvantages of the detergents also because they contain some branch chain hydrocarbons which are not easily biodegradable. Then how to overcome the environmental hazard of soaps and detergents, although both are useful, but both are causing certain environmental hazard also. The best way is to avoid the unnecessary and excessive use of soaps and detergents. So this is what we have discussed today, that what are oils and fats, what are their structure, their properties, factors which are used for their analysis, how is the soap obtained, cleansing action soap, and then detergents.
With this note, thank you sir, thank you so very much for giving us a very productive session on fats, oils and detergents. I hope that all the students who might have watched us right now would be benefited from this particular lecture. As we always say, if you want to access this particular lecture, of course you can access is with the help of YouTube, as we daily upload our lectures on the YouTube. Thank you sir, thank you so very much.